Hello everyone, welcome to the channel. So in the previous video with regards to the database management system, I was explaining the DDL, DML, DCL and TCL commands which are present. So what are the instructions which are present? SQL as a comprehensive language. So it includes the DDL. DDL stands for data definition language, which is used to create and define the database, and DML for performing the manipulations on the existing database. That is, you're inserting a new record, updating the new record, and or deleting the existing record from the existing database, or selecting or retrieving a few records from the database. Now coming for DCL, that is data control language. So this is associated with the database administrator. He will have all the authority to give permissions, that is grant permissions to the user, or revoke means take all the permissions from the user. Now TCL, it is called as transaction control language. So it is used for managing transactions in the database. That is, for example, if you are going to Paytm, Google Pay, and also, for example, if a user is going to pay the money for availing any service, then how, that is also one transaction only, right? So how does the transaction going to happen? So in that we will come across these commands, that is commit, rollback, save point, and all those things. So make a if a user is going to make any transaction, then how does the transactions get updated? So now view definition, it is used to create a virtual table. So this was the brief explanation. Now coming for the slide which you are able to see, that is your DDL, DML, DCL, TCL and others. So what it is meaning? So DDL stands for defined database structure, and also to create the database. So create, alter, drop. Now DML, it is used for managing the data, that is select, insert, update and delete. And now for DCL, we'll be using control user access, that is a grant and revoke. TCL for managing transactions. Now SQL data definition. So before we go for data definition, so we should understand what are the terms we will come across when we are going for a database. Now, a relation, tuple, and attribute. So a few people is going to pronounce this as tuple and few people as tuple. So it is your convenience. So a relation, tuple, and attribute. So what does this relation means? So this relation, it is going to define the relationship which is present between the two entities. Entities are nothing but the tables which consist of rows and columns. So in DBMS, rows are considered as tuple and column is considered as the attribute or a field also. So tuple means it is a row or a record. So one complete entry. Now column or field, so it is the attribute. So a property of the data like name or salary. Now, what is this SQL data definition language? So now data definition language, as you all are able to see, this is also called as DDL. So DDL, it is used for defining, modifying and deleting the database structures. So SQL allows users to define, modify, and delete database structures. So the command used for this are called data definition language. Main DDL command which we'll be using is to create the database. So what does using this create command, what and all I can do? So I can create schemas, I can create tables, domains, views, constraints, triggers, everything. Now earlier SQL versions. So before SQL 2, we didn't have the idea schema. So what is this schema? What do you mean by schema? So the schema consists of the columns, that is the attributes which are associated with the related database. Now all tables were considered as part of the single global database. Now modern SQL, that is from SQL 2 onwards, schema was introduced. Before that, schema was not there. So schema is nothing but like a folder which the groups together all the related database objects, means tables, views, constraints, means it is going to give a snapshot or the overview of the database structure. So each schema has name, authorization identifier, elements, everything. Now create schema company authorization JSmith. So here they have given an example. So this creates a schema named company owned by the user JSmith. Who can create schemas? So this is very important to be noted. Not everyone can create schemas. Only the database administrator, who is also called as the DBA, must grant permission to users who are allowed to create the schemas. Now, what is a catalog? Catalog is a collection of schemas within one SQL environment. It is a group of schemas. Now, SQL environment means one installation of an SQL-based DBMS like Oracle, MySQL. I have come across many such softwares. That is MySQL Workbench, MySQL Command Line Client, all those things. SSMS. So those all are. Now, each catalog includes a special schema called information schema. So this schema stores metadata. So metadata means data about the data. So it is the information about all the other schemas, tables, and columns. Now, integrity constraints. The moment I tell integrity constraints, we should understand it is the foreign key constraint. So it can be defined only between the tables which are present in the same catalog. So as I have already told you that catalog, it is a collection of schemas within one SQL environment. Now, the schemas within the same catalog can share elements such as domain definitions. Now we will come across with creating the table command in SQL. So create command, it is used to create new tables, that is relations within the schema. So this is the syntax which you are able to see at the screen. So create table name. So bracket open, that is the parenthesis open, column name, data type, and the constraint which is present. So constraints are whether it is a primary key or a foreign key or what, everything you will be mentioning. So table of constraints, and then you will be closing it with the closing parenthesis. Now, here the example you're able to see. So in this example, we are creating the employee table. So under employee table, fname varchar. So varchar, it is the data type which is associated for the attribute called fname. So varchar of 15. So fname can store a string which is the length of 15 or less than 15, not more than that. And it should not be null. So this is the constraint. If you're giving null value, then it won't insert. So that is the problem. Now, minute character. Lname varchar not null. SSN can not null. So like this, I will be creating. And now here you are able to see primary key SSN. So primary key SSN means this attribute is going to act as the primary key. So in this video, I will be telling a short within 1 or 2 sentences about primary and foreign key. Now, many of you would be knowing, but still I will tell primary key, it is going to uniquely identify each and every record in the table. Means primary key, if an attribute is supposed to be a primary key, then the records which are present corresponding to that particular attribute must not have redundant values, and it should not be null. So if it satisfies those two constraints, then I can call that attribute as the primary key. Now, primary key is associated only with one table, but foreign key is also, it has same properties only like primary key, but this foreign key will be associated with more than one table, that is two tables, like that. Now this is the way how we will be creating the table in the SQL. Now, attribute data types and domains. Now in SQL, every attribute in a table must have a data type. So why each and every attribute must have the data type? So what kind of values I can store in that column in the table? Now how much space that value is going to take? What operations I can perform? So to know all these things, I need to mention the data types and domains. Now different categories of data types. So numeric data types. So these are all self-explanatory. By looking at this, you will be able to understand. So integer, it is the int, means it is used only for storing whole numbers. Small int means only smaller whole numbers, which it takes less memory compared to integer. Now floating point types. So it is used for numbers with decimal, that is float or real. Double precision. Double precision means for very large or very precise decimal numbers. Formatted fixed numbers, if you want to control how many digits can appear before and after the decimal point, so then you will be using this formatted numbers. For example, salary decimal 7 comma 2. So 7 comma 2 means in this case it is going to tell that basically 7 numbers should be present in the number, and only 2 numbers should be present after the decimal. So this is the example which you are seeing, 12345.67. Now, character string data types. So it is used to store text, that is letters, words, or symbols. So it is fixed length strings. So character of n, or this n indicates the size, means how many characters I can store. So it stores exactly n characters. Character of 10 means Smith becomes Smith. you are able to see the difference from here to here. Means it consists of like 1 2 3 4 5. Here 1 2 3 4 5, and remaining these things it will be kept as space and then it will be closed. Now variable length strings means then I'll be using varchar. So these are all the data types. Now string concatenation. So you'll be using double parallel lines to join two strings. Now ABC XYZ means ABC XYZ. Two straight lines I'll be using to combine the strings. Now CLOB, character large object. So it is you can specify the maximum length. So CLO description CLOB 20 M means it will show up to 20 megabytes of text. Now Boolean data type. The moment I tell Boolean, you all should be able to understand it is sophisticated with true or false values. So true means 1, false means 0. Boolean means 2, binary values. Now but in SQL because of null there is a third possible value. So true, false, unknown. Date and time data types. So date it is used to store date. So this is the format. First year, then month, and then date. So 2025 10 22. So this is the example. Now time, hour, minute, second. So this is how we will be storing the time and the date. Now in SQL. So domain is a user-defined data type. So it helps you reuse the data type in multiple places and makes your database more readable and consistent. It also helps in maintaining the data consistency, data integrity, and reusability. Now create domain SSN type as character of 9. So instead of writing character 9 in many tables, you can just use SSN type. So SSN type. You can also set a default value. Now categories. So these are the categories: numeric, character, bit string, boolean, date or time, interval, domain. So these are all the categories of the data types. Now specifying basic constraints in SQL. So how I am going to set the constraints. The moment I tell constraints, you people should know what is a constraint. What is the general meaning of constraint? Constraint is nothing but the condition which you are setting for the database. Now specifying attribute constraints, key and referential integrity constraints, giving names to constraints, specifying constraints on tuples using check. So check, this is also one of the constraint. This will be using most of the times while creating the table itself. Now attribute constraints and defaults. What type of constraints? So not null and default check constraints. So these three conditions will come under attribute constraints and defaults. Now key constraints are primary key, unique. Now referential integrity. So referential integrity means it associates with two tables. So that is why we will be taking foreign key under referential integrity. Like on delete cascade, set null, set default, like actions on update or delete also will be considered under referential integrity. Now named constraints. Now giving a name with a constraint so you can drop or alter later. Now tuple level check. So constraints that apply to the whole row. Now assertions, more general constraints. Now attribute constraints and attribute defaults. Not null. The moment I tell not null in the database, you can't enter the null value. Simple. This is the example. SSN char of 9 not null. Now default. So default value supplies the value automatically when an insert does not give one. Means suppose if a user is not inserting the record in the database, then a default value will be stored. Now check constraint. So check attribute level and domain level. Check lets you to restrict values with an expression that must be true for every inserted or updated value. So while creating the table itself, you will be calling the check constraint and then you will be restricting the user to store only such type of values which will satisfy the check constraint. For example, in not null check means d number, the attribute d number while we are inserting should be greater than 0 and should be less than 21. Now, domain level reusable. Now defines outside of tables as a reusable data type. Now, why we need to use domains? So reuse the same rule in many tables and change it in one place later. Key and referential integrity constraints. Now, primary key. As I said already, it uniquely identifies each row. Values must be unique and not null. Now, unique means it can store null values also. It can have null values also, but the condition is it should be unique, means all the values should be distinct. There should not be any redundancy. Now coming for foreign key, that is your referential integrity constraints. So this deals with the two tables. A foreign key, so which one I am considering as foreign key and from which table I am taking the reference. So here this is the example. Now, when we have two related tables, one is the parent and the other is the child. So I am creating two tables here. So create table department, create table employee. So in department table, I am having department number, department name as the attributes, and department number is the primary key. Now create table employee. So employee ID int primary key. So in employee table, this is the primary key, employee name, department number, and foreign key. So this department number I will be referencing from department table. So department is a parent table, employee is the child table. So it references the department. It is going to take the reference from the department. Now actions on delete or update. If a reference parent row is deleted or its key updated, you can tell the DBMS how to handle the child rows. Means if you are doing any modifications in the parent table, then how we can reference the child, how we can get to know the DBMS. Now reject the operation that would break the referential integrity. Cascade. So there are two types of cascade. One is on delete cascade, another one is on update cascade. On delete cascade, delete all referencing rows when the parent row is deleted. Means in the parent table, if I am deleting a particular row, in the child table, which rows are referring that deleted row in the parent table, those all child rows should be deleted. Now on update cascade means change referencing FK values to match the new parent PK value when it is updated. Means I'm going to just update the foreign key values to match the new parent. Set null. On delete set null. Set the referencing foreign key columns to null. On update set null. Once you do the updations, set it null. Set default. Set the referencing columns to the specified default values. Now, this is the in short form, in a tabular form, you are able to see restrict, cascade, set null, set default. So these are all the operations and what are going to happen once we perform on delete and on update. Now, when to use which action? So cascade is good for relationship tables. So when we are having a relation which is built between the two entities, or when we are having weak entities, then using cascade is good. Set null or set default are safer when you want to keep child rows but remove or mark their parent reference. If I want to remove the parent reference and if I want to keep child rows, then using set null or set default is the best option. Now coming for the restrict, it is safest when deletions must be explicitly handled by the application. Now, naming constraints. So, constraint name to give a constraint a name. So, you can give name to a particular constraint also. So, sometimes we can write the constraint with the attribute itself. Sometimes I can add a separate line mentioning it as constraint and then give my own constraint. So like this also I can create. So what is the syntax which is associated with naming the constraint? There is constraint, constraint name, constraint type, and the columns which are associated with that. Now, tuple level check. So this is how, as I have already said that during creation of the table itself, we will be performing the tuple check. So create table department. So I am basically creating a new table department. So in this department, I'll be creating the department number, which is going to be the primary key, department create date, which is going to store the values in date format, manager start date in date format, check means here I'm going to give an explicit condition that department create date should be less than or equal to manager start date. So I need to insert the records in such a way that it is going to satisfy this check constraint. This ensures that each manager's start date is not earlier than the department creation date. So this check is evaluated for every insert and update of the row. Now you can put multiple constraints also. See, you are able to see in this example itself. See, this is one of the constraint. So this is taking references on delete on update. So four constraints I have put here. So you can create, you can put multiple constraints in one table, one command itself. With this note, I will be ending the video. So further concepts I will be explaining in the upcoming video. Please keep sharing this video to everyone such that it is going to make them easier. Thank you.